Hello folks, welcome to CodeCrucks. In this video, we will look at some examples for which we will construct DFA and NFA so that you will get clear-cut idea that how NFA differs from DFA or how easy to construct NFA compared to DFA. Our first language is set of strings which are ending in 00. So if we enumerate the strings, then smallest possible length string would be 00. Then it would be strings of length 3, which is 000 and 100. Then strings of length 4 would be 40, 0100, 1000 and 1100. And then we have a set of infinite such strings. Remember, whether you derive DFA or NFA, we should always start with the smallest length string. So first we'll derive DFA for 00. And then we'll adjust the arc so that we can generate all possible strings in L. So that is very simple, that from Q0, if we read 0, we will be in some non-final state Q1 because 0 is not acceptable. But when we read second 0 from the Q1, we can go to the final state Q2. So this DFA only accepts string 00. We have to make sure it accepts all the strings ending in 00. So now we will start adjusting the arcs. So we'll start from Q0. And we'll see if we can generate self loop of 1 or not. So if we put the self loop of 1, all strings are valid because we can read any number of 1, but to terminate, we must have to read 00 to go to the final state Q2. So that is valid. So both the arcs are generated from Q0. From Q1, can we place 1 as a self loop? No, because if we put 1 as a self loop, then we can read 0, 1, 0, and we would be in final state Q2. So that string is not valid because it does not end in 00 and still we are in final state. So now we have to look for the other alternative. Okay, we have to now go for the next or previous state. So from Q1, if we generate this arc to Q2 on input 1, then also it is not valid because otherwise from Q0 we will read 0, we'll move to Q1. From Q1 we can read 1 and go to Q2. So 0, 1 is accepted, but it is not in our language. So that arc is also not possible. So only possibility is we can go back to Q0 because we know that once in Q0, without reading 00, we cannot go to Q2. So this will add some more strings into the set of strings generated by DFA. From Q2, can we read 0 from the same state? Yes, obviously we can read because it will generate 0, it will read 000 and all the strings would be ending in 0. Right? So that property is true. Can we have self loop of 1 from Q2? No, that is not possible. Otherwise our string will end in 1 as well. Fine. So we cannot put self loop of 1 on state Q2. Let's look for the previous state. Can we have arc from Q2 to Q1 on 1? No, that is also not valid, because otherwise string 0, 0, 1, 0 will be accepted. If we have arc from Q2 to Q1 on input 1, 0, 0, 1, 0, that is accepted, which is not ending in 00. So this is not valid string, still it is accepted. So we cannot have an arc from Q2 to Q1 only. So we have only one possibility to have arc from Q2 to Q0 on input alphabet 1. Because we know that if we are on Q0, there is no other way to reach to Q2 without reading 00. Right? So this is a valid transition diagram or a DFA, where for any input symbol from any state there is a unique or the deterministic transition. Let us derive NFA for that. In NFA, first we'll derive the smallest possible string, that is 00. Now we know that 00 should be at the end of the string, right? Or string should end with 00. Before that, we can read anything. So if we add arc of 0, 1, we can produce any string of 0 and 1. And to terminate, we will go to the final state Q2 by reading 00. So this is simple and quite easy. We don't need to adjust the arc from Q1 or Q2. This NFA itself is as powerful as DFA shown above it. So you see that construction of NFA is quite simple compared to DFA. Let us consider another example where string contains substring 101. So smallest possible string would be 101. then strings of length 4 would be 0101 and 1101. Then it is a substring not ending, so we can have 1010, 1011, etc. and so on. So to derive DFA, first we'll construct the DFA for the smallest possible string 101. So that is accepted. Now we'll try to adjust the arc. Can we have arc of 0 from Q0? Obviously we can have. We can read any number of 0, but to reach to the final state, we must have to read 101. So 101 will be definitely the substring. From Q1, can we have arc of 1 as a self loop? Obviously we can have, because after reading first one, we can read any number of 1, but to go to the final state, we have to read 0, 1. So 101 will be definitely into the string. From Q2, can we have arc of 0 as a self loop? Obviously not, because otherwise we can read 1, 0, then 0, 0, 0, 0, 0, 0, 1. We will be in final state. And that string does not contain 101 as a substring. So that is not possible. The arc of 0 from Q2 to Q3 is also not possible. Otherwise, it will read 1, 0, 0. Arc from Q2 to Q1. Is it possible? If we do that, then our string might be 1, 0, 0, 0, 1. That will be accepted. I repeat, if we put arc from Q2 to Q1 on input symbol 0, then our DFA can read the string 1, 0, 0, 0, 1. It is accepted, and 101 is nowhere into the string. So that arc is also not possible. So only possible arc is from Q2 to Q0 on input 0. So once we are in Q0, we already know that we cannot go to Q3 without reading 101. So that is the incremental generation of DFA. And from Q3, can we have arc of 0 and 1 as a self loop? Obviously, because when we are in Q3, we already have read out 101. So we can put self loop arc like this. Fine. So this is the DFA. For NFA, first we'll construct the NFA for 101. 101 is a substring. So before this we can read anything, and after this we can read anything. So this is the NFA for language strings containing substring 101. So this NFA will produce all the substrings which the previous DFA is generating. But the construction is very, very simple. The next example, strings containing substring ABB. So ABB should appear as a substring. So first we'll derive DFA for that. This is ABB. And now we will verify whether this is sufficient or not. Obviously it is not, because it produces only one string ABB. We have to generate all which contains ABB. So from Q0, we have to check for arc B. Can we have a self loop? Yes, we can put, because after reading any number of B, we must have to read ABB to reach to the final state. So this is valid. From state Q1, can we have arc of A as a self loop? Yes, it can be, because after reading first A, we can read any number of A from Q1, and then we have to read double B to reach to Q3. So obviously A double B will be there in those all the strings. From state Q2, can we have self loop of A? No. If we do that, then it will read string A, B, any number of A, then B. So ABB might not be in those all strings. So that arc is not valid. Similarly, from Q2 to Q3 is also not valid. Otherwise, it will read ABA, which does not contain ABB. From Q2 to Q1, can we set arc of A? Yes, we can read obviously. Fine, because suppose we are reading first A, then B, then A, then we must have to read double B to reach to Q3. So ABB is there. So if you consider any combination of strings using this DFA will definitely contain ABB as a substring. What about Q3? Can we have self loop of A and B on Q3? Obviously, because we already know that when we are in Q3, we have already read out ABB. So we can have AB as a self loop. So this is the transition diagram for given language. For NFA, first we'll construct the basic NFA, that is ABB, and ABB should be substring. So before this we can read any string of A and B, and after this also we can read any string of A and B. So this is valid NFA for given language. Let us consider the language, all the strings over alphabet A, B that starts with A and end with B. Okay? So it should start with A and it should end with B. So this is valid. Okay. Now we will adjust arc to generate all the strings. Can we have self loop of B on Q0? Obviously not, because otherwise our string will start with B as well. Okay. Can we have, so that arc is cancelled. Can we have arc of B from Q0 to any other state? It is not possible, because it is said string must start with A. So there is no other possibility to read B from Q0. Okay. And from Q1 definitely we can read A. So we can have any number of A followed by B. So string is starting with A followed by any number of A and then it is ending with B. So this is totally valid arc. From Q2, can we have a self loop of A? No. Otherwise the string will end with A as well, and which will not be valid. So we'll look for the previous state. Can we have this kind of arc? Obviously. Because from Q2, if you read A, string is not ending in B, so it is not acceptable. So it is going to some non-final state Q1. From Q1, if you read B, you are going to final state, because now your string is ending with B. So whenever a string is not ending, we will be always in non-final state. When it is ending, we are in final state. And what about another alphabet B? Can we have a self loop on Q2? Obviously we can have, right? So we can produce all the strings which are ending with B. So this is the desired DFA. To construct the NFA, first we'll construct the basic NFA with string A and B. And we know that all strings over AB that starts with A and end with B. So we can read anything from Q1, okay? Because it is already starting with A. Then we can generate any combination of A and B, and to end we have to go to the final state Q2 by reading B. So this is the NFA for, given language. So in this video we have discussed various examples and we understood what is the difference between DFA and NFA from the point of construction. As we saw that NFA construction is very simple compared to DFA. And in upcoming lectures, we will also discuss how to convert this NFA into DFA and how to optimize our DFA. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.